here. Yeah, preparing to live stream the meeting. Let's see. Oh, here we go. We are on. So I'll flip over to the title over here. So welcome to UAB Data Science Club number 38. You got Ravi and William here, and we're talking today about essential data cleaning for machine learning. So I think in the next few weeks, we want to start doing some R and Python, or not Python, but some R and MATLAB stuff. We've been doing a lot of Python, but I think that it's going to make sense to do some MATLAB and R. But this tutorial came up and it's going to be helpful for some of the projects that we're working on. And so we thought that it would also be helpful for other folks. And these techniques should still be universal across programming languages. It's just a matter of what the exact syntax is. So if you're trying to do this in MATLAB or R, just let us know and we'll happily set up a Zoom and we can talk about it.
Yeah,
Robbie, go ahead.
Yeah. I mean, generally, the algorithm is the most important part in programming. So, if you know the method of how you want to achieve a particular goal, that's the algorithm, the method, how you want to achieve it. Then, technically, even if you are doing it on Python or you are doing it on MATLAB or R, the algorithm remains the same. The syntax you can find either via Googling or going through the books of that software. Yeah, I mean, so the most important part is the concept that we are going to be talking about. And once you have that, you go on R, just search for, I need to do data cleaning and I need to do this particular task for data cleaning. And there should be, I don't know, dedicated questions regarding it, or you'll find helpful information over there.
Yeah, absolutely. I see you're joining from Mars today.
Yes. I wanted a change in scenery. Earth was getting too viral.
Yeah, the Matrix was too restrictive, so now I'm in a dungeon. Anyway, so let's get on to the tutorial. So we're doing this basic data cleaning for machine learning on machinelearningmastery.com. If you get his newsletter, I think it was one of the ones he published this week. He published it on March 20th, which I think is that yesterday? No, that's today.
Yeah, today.
Oh, okay. I don't know how it showed up. Oh, apparently he scheduled the post from yesterday because it went out in his email.
Okay.
Because both Ishan and I got it today or yesterday. Anyway, so we're going to do that. And in here, he's just running a Python script, but we're going to run this inside of a Jupyter notebook on the Chiha supercomputer at UAB. And so we're going to go to rc.uab.edu. We're going to log in with our credentials and then go over to interactive apps and then Jupyter notebook. And let's see. And since this is data cleaning and we're not actually doing machine learning, we can probably use just the CPU partition instead of having to have a GPU. I'm going to change this to Express and 1 hour, because if we spend longer than that, I'm late for another meeting. And then 4 CPUs and 16 gigs of RAM should be fine. So I'm going to hit launch here.
Yeah, and I mean most of the things that we'll be doing in this this tutorial or this basic data cleaning methods are not going to be GPU oriented tasks. So technically we'll just be asking for that resource and not using it, which is not useful.
Yeah, it's not being a good citizen at that point.
Yeah.
All right, so I'm going to click on this connect to Jupyter to bring up my notebook, or at least my folder. And then I'm going to create a new notebook with our NBOTW environment. Okay. And I'm going to change the name to basic data cleaning.
And so the NBOTW notebook that William just mentioned is the Conda environment that we created in our very first episode that contains all the libraries that we have been using, I think, throughout our playlist. Whenever we run anything on Chiha in a Jupyter notebook, that's the library that we generally go to. So like pandas and Keras and all the other libraries are already present there, so we don't need to go and create a new environment every time.
Yep, absolutely. And that way we're all kind of on the same level playing field. I would say that if you tried to check that notebook out or that environment out today and build it from the repo that we send out in that first video, it's going to actually work a lot nicer than it did in that initial repository. The data science interns that we have just did a really good job of reworking that README and the excuse me, the job to create the environment. So so you shouldn't get any errors there, but if you do, let us know. All right, so let's start scrolling down. As always, we're assuming that if you're watching these videos that you can read, and that if you want to, you can go back and look at more of these specific results. And let's see. Okay, so this tutorial has 5 parts. We're going to identify columns that have a single value. We're going to delete those columns, and we're going to consider removing columns that have very few values. And we're going to identify and remove rows that contain any duplicate data. That seems like a reasonable first step to any analysis problem. I don't know that that's particular to just machine learning, but it's certainly
Yeah, it seems that it would be useful since it is sort of feature reduction that we are doing. We are removing features that don't add anything to a machine learning model. I mean, if every value is like in the example that they have shown above, if every value is 1, then that's not a feature from which you want your model to be learning anything, because it's common for in all scenarios.
Yeah, exactly. It's not going to learn anything if the values are all the same. So that's exactly right. Or we may even, in an even worse case, you may have something that's not only 1, but maybe you have 2 classes you're looking for, and maybe there's a second column that's just another code for whatever your target that you're trying to predict is, in which case your machine learning still isn't learning anything other than how to map one code to another code. All right, so this first chunk is going to be just loading in the data. And let's see, so it's saying, all right, summarize the number of unique values in each column. All right, so let's do that. All right, so the first thing that it does is this URL lib allows us to open a data set directly from a URL. So we don't have this database, this oil spill CSV local to Chiha. It's at this githubusercontent.com. And so this allows us to open it directly from there.
Yeah, this is a simpler. I mean, it's a coded method of getting down data. I mean, it's similar to if you just went to that link and downloaded it yourself and then moved it up to Chiha and put the path over here wherever you actually move the data to. But rather than going through
Yes.
all those manual steps, you can just give the path from which you want to download data over here.
Yeah, absolutely. And if you did have this local, the only thing you would need to change here is to remove this URL open, and it should still load up the data.
Yeah.
And of course, update the path to the absolute path on your machine.
Yeah. So technically, you wouldn't save much time, but you'll actually spend more time in all the manual method.
Yeah. All right. So now if we look down, we can see that some columns have 927 unique values, some have 57. Column 22 apparently only has one. So that looks like a good candidate for us to remove.
Yeah.
So let's come down here now. Oh, okay, so this next block, we don't have to do this piece unless we're using the data frame later. Oh, they're kind of building it up one piece at a time. Okay, that's fine.
Yeah.
So we're gonna do this. So we're gonna do the same thing with pandas. Apparently with pandas, we don't have to use the URL lib. Pandas can read it directly from the URL.
Yeah.
All right, and so this just shows that using pandas, it's even less coding to get that same number. So we're going to read in this oil spill CSV into a data frame, and then if we use this nUnique function, it'll show us the number of unique values per column. Okay.
Yeah, I see there is 45 and 49 also that have only 2 unique values. That can be an issue.
Yeah.
But I mean, the only issue with any of these features having such less number of I don't know, less number of unique values is then that your model can overfit a lot. With one, it doesn't make a difference. That's why we are removing it right now. Even with two, I can see a scenario where it might just overfit based on these two features.
Mm-hmm. Yeah, absolutely. All right. So now what we want to do is we want to, any column that only has one value, we want to remove. And so that's what this next chunk does. All right. So again, we're creating a pandas data frame from the CSV file. Instead of printing out the unique values, what we're going to do is we're just going to put those in another variable, and then we're going to loop through them. And if the shape of, or if the number of unique items in that column is equal to 1, then we'll save that column to delete, and then we can delete it from the data frame directly with this drop command. So data frame dot drop with the indices to delete, and then axis equals 1 means we're deleting an entire column, and in place equals true means that it's going to go ahead and do this operation to the data frame. If that was equals to false, then we would have to put the result into another data frame in order to save it. So let's do that. So yeah, so then what this is just showing is that initially the data frame has 50 columns, but then we're going to delete number 22. And then after we delete number 22, we have 49 columns. All right, so the other thing we want to take a look at is, are there any columns that have just very few values? Because like Rob, you mentioned, even if it has just 2, it's either not useful or too useful.
Yeah.
Potentially it could have some meaning, but there's always the potential that it could have some issue.
Yeah, I mean, so like William and I always mention that it's always good to have a look at your data set, have a look at the features that are there. So like when we were removing this 22nd column, right?
Yep.
We
Yeah.
dropped.
22.
Yeah. So when we were removing that, since it had only one value, it was useful to just remove it. It would be a good idea if you guys are doing it to take a look at the column value or column name and what that column is specifying, just to have an idea whether it makes sense to remove it or not.
Yep. Yeah, and that absolutely makes sense. So what this chunk of code here is doing is we're again importing the libraries. The guy that writes these tutorials does a really good job of, he always wants each cell to work. And so he puts everything you need to run that cell inside of the cell a lot of times. And this tutorial is one of those cases. So we're importing our libraries. Again, that's our path to our CSV file. We're loading the data. And then for every column that we have, we're going to find out the number of unique data points in that column.
Yeah.
And then we're going to divide that number by the total number of elements in that column and multiply it by 100. So basically, we're just getting a percentage of unique values in that column. So if the column is 100% unique values, then we essentially have an ID for each case, which that on the one hand, that's not useful. But then on the flip side, if we have something that's too few, maybe we have like less than 1% unique values, then that also may not be a useful thing to keep.
That's a very good point. Even if your numbers are like 100%, I don't know what to call this thing, but if they're 100% unique, like every row has a separate value, then they won't be very useful for your model too. I mean,
Yeah.
then again, it cannot learn anything from that feature if it is
Yeah.
going to be unique every time.
Yeah, so that would be like when we did that example on home retail value.
Mm-hmm.
If we had kept the street address as a predictor, that's not really that helpful, because the machine learning doesn't know that 555 Roger Road is next to 556 Roger Road. It doesn't have a map.
Yeah,
all it's going to know is that those are two separate values.
yeah, definitely. I mean, yeah. So too few unique problems can be an issue, and too many unique values can be an issue too.
Yeah, and so in this case, we're going to bring that in, and you see that column where it only has one unique value has 0.1% is unique, which makes sense. I think there's like 1,000 rows in this data set.
Yeah.
So if we do this next piece, again, this is the same chunk of code, except with the difference that instead of just printing the percentage, we're only printing it if the data was less than 1%. And this is so that we can decide on those particular columns, do we want to remove those or no? And that would, I don't know, for me, that would require knowing a little bit about those columns.
Yeah, I agree. I mean, one, definitely you can remove it. Two, okay, I mean, I would still be okay removing it even if I don't know much about columns. Whenever you get to values like 8 or 9 values, or even anything above 5, I would definitely like to look at the column name, what it's signifying in the overall picture of the data set.
Yeah.
It could be that it highly corresponds to what you want to find out, but then that column is already giving you the answer of what you want to find out. So
Yeah. Well, and so like there's definitely instances, I like this point that he makes about the categorical values, that if you only have two values, maybe it's a categorical value. So like if you were trying to predict whether or not somebody had some type of illness from a set of spreadsheet values like this, it's very common that you include the gender of the person or the age as a covariate, so you make sure that you remove whatever impact on the data that value has. And so in that case, you would maybe keep it in, depending on whether or not it was an important variable, but it would only have two values, regardless of how many other values you add in.
yeah, I mean, yeah, I think that it's a good point about the values like gender or something. I remember in the interview that we had with sorry, I
Patrick,
forget the. Yeah, when we were talking about these kind of things creeping into the data set, where some bias creeps in and that impacts the model that you're creating. And yeah, so just having a good idea about these kind of features whenever you see them would be a good idea to not let bias creep into your models.
yeah, yeah, no, I absolutely. So this next little chunk, what this does is just goes ahead and does that logic. So you can certainly do that if you want to. I'm not going to here, just because I don't know enough about this data set to know whether or not it makes sense to do that, but it's here if we needed to do it. Basically, it's the exact same code as before. Instead of saying if the number of values equals 1, we say if the number of values divided by 0 times 100 is less than 1. So as long as it's less than 1% unique, we're going to remove that, which again may or may not be productive in this case.
Yeah.
All right. The other thing that may happen is duplicate data, which could oversample and potentially overweight our machine learning algorithm to a particular outcome. And if it's got duplicate data, it may not be worthwhile keeping. So let's load in again that same, okay, this is a different one. So this is the iris data set. So another famous data set. This one is for classifying different types of different subspecies of the iris flower just based on measurements. And so we're going to upload that, and then we're going to print out the duplicates. Just see how many there are. Okay, so it looks like row 34 and row 37 are duplicated. And then I'm not really sure why row 142
Yeah, I don't see the duplicate value that
is in here, but maybe it's saying that that's a duplicate of another value.
Maybe.
Row duplicates. Okay. In this case, we can see. Oh, okay. So yeah. So basically, yeah, that's what it's doing. So it's not printing out every instance of the duplicate rows.
Oh, so there are three rows that have this iris setosa with all these exact values, but it is only showing us two of them.
Yeah, it's showing us the two later ones.
Okay.
And so similarly, the iris virginica, there's another row that has that same value, those same values. We're just not seeing it here.
Yeah. One important thing with this duplicated function is that it's going to check the duplicates across the entire row. I mean, all the features in a row. It's so that it can see that the entire row has been duplicated, or entire data for one instance has been duplicated.
yeah, it's really gonna, ensure that the entire sample is a duplicate sample and not just really, really close.
Yeah.
Because if it's really, really close, then we probably want to keep it. Because that tells us something else about our data.
Yes.
All right.
I mean, yeah. So this issue is very similar to if there are like 5 people voting for something and one person gets 10 votes, then whatever he chooses will go. So if you have a lot of duplicates, then that would have more say into your model.
Yeah, absolutely. Absolutely. All right, so I think this is the last cell that we have, but this is just going ahead and deleting those duplicates. And so again, we're importing the CSV file. We're doing this with pandas again this time. And then we're going to read that CSV file. And then we're going to just drop the duplicates. And so pandas is really nice from the standpoint of a lot of these standard data cleaning things just kind of come built in to pandas, and so it allows us to do that, which is nice. And so we can run that, and what we'll see is, yes, indeed, we dropped 3 rows after eliminating the duplicates. All right, let's see. Oh, cool. There's another turning messy data into tidy data. We might have to do that one in the future. I don't know if what language is this one in? Oh no, that's just the philosophical article. Okay.
I enjoy that, but generally we tend to keep our videos where we have some code behind it as well.
Yeah. What? Again, we kind of assume that if you're watching this, you're able to kind of read an article like that. If you read that ID data one, you have any trouble with it, we're happy to talk about it, because the concept is really, really useful, and it's just something that we're kind of just now really getting into. So we'd be happy to kind of converse about the issues regarding turning messy data into clean data or messy data into tidy data. So yeah. Well, thanks guys for hopping in whenever it is that you do, and we look forward to doing another data science club next week. I don't know what tutorial we're going to do next week yet, but we'll figure that out.
And if you guys want us to focus on any particular topic, just let us know, and we can do a video on that.
Yep. Sounds good. All right. Well, stay safe, Robbie, and everybody else out there, and we will talk to you guys later.
All right. Talk to you later.